In this video, I'm going to talk about one of the most important aspects of materials engineering, that is microstructure. Now you know how atoms come together and form DNA, which essentially dictates how humans behave. We often say it's in their DNA. A similar concept applies to materials too. Atoms come together and arrange themselves in specific ways that we refer to as microstructures. And just like how DNA dictates human behavior, microstructure dictates how a material behaves. Now, in this video, I'm not going to go into the technical details of microstructures. I'm just going to give you a conceptual understanding of what microstructures really are. So microstructure, as the name suggests, is the structure of the material at the micrometer scale. It's not at the visible scale, not at the atomic scale, but at the micrometer scale. When we zoom in on a material using a microscope, we don't see uniform blocks. We see features such as grains and grain boundaries. Now, grains are regions within a material where we have one specific type of atomic arrangement, and grain boundaries are where this atomic arrangement changes its orientation. We might also see things like precipitates, inclusions, and vacancies. And the most important part is the way these features are arranged within the material is what dictates its final properties. Now let's take an example. Steel can have a very different microstructure depending on its composition and processing. Two classic examples are pearlite and martensite. Pearlitic steels have an ultimate tensile strength of about 600 megapascal, while martensitic steels have tensile strength of about 900 megapascals. Same material, same composition, different processing, resulting in a different microstructure and significantly different final properties. Now imagine you have to carry elephants on a 1 meter square steel plate which has a pearlitic microstructure. Now one elephant weighs about 5,000 kilograms. So can you estimate the number of elephants that you can carry on this steel plate before it fails? And by fails, it means that when the stress on this particular steel plate goes above its tensile strength. You can comment your estimates, and the first correct answer with the proper calculation will win an elephant. So, materials engineers don't just choose elements, they control the composition and the processing of the material to achieve the desired final properties. Just like DNA dictates human behavior, microstructure dictates a material behavior. And that is why microstructure is one of the most important aspects of materials engineering. So don't forget to comment your answers, and as always, I'll leave the link to submit your questions or doubts as well as your memes. See you in the next one.